Hey everyone, welcome back to Avbron Tech. Today, we're diving into a core concept in Java: traversing collections using iterators. We'll explore how iterators work and look at some practical examples. So, let's get started. Setting up the collection. First off, let's create a simple collection. For this example, I'm going to use a collection of book objects backed by an array list. Let's go ahead and populate our list with a few book titles. Creating an iterator. Now, to iterate through this collection, we need to create an instance of an iterator. We do this by calling the iterator method on our list. Iterator book iterator equals booklist.iterator. This gives us an iterator instance that we can use to traverse the book list. The iterator starts before the first element in the collection. Using the iterator to traverse the collection, to access elements, we use the next method. Each call to next moves the iterator forward and returns the current element. Notice how each call to next advances the iterator to the next book in our list. It's important to note that if we keep calling next, after the iterator has reached the end, we'll get a no such element exception. Iterating with a while loop. Iterators are typically used with a loop. A while loop is perfect for this. Here, has next checks if the iterator has more elements. If it returns true, we continue the loop. Otherwise, the loop terminates. Using multiple iterators. An interesting feature of iterators is that each iterator instance is independent. Let's see what happens when we create a second iterator. Both iterators start from the beginning of the list, and they independently track their positions. This means first iterator and second iterator can traverse the collections separately. Enhanced for loop. In modern Java, the enhanced for loop, or for each loop, is a more concise way to iterate over collections. It implicitly uses an iterator under the hood. The enhanced for loop simplifies our code and is the recommended approach for iterating over collections when we don't need direct control over the iterator. Understanding iterators is crucial when working with collections in Java, especially when you need that granular control. If you found this video helpful, don't forget to like, share, and subscribe to tackle a common issue that many Java developers face when working with collections: modifying them while iterating. If you've ever encountered the concurrent modification exception, you know how frustrating it can be. So let's dive into how to avoid this and explore some safe alternatives. Understanding concurrent modification exception. First, let's set the stage with an example. Here, I've created a collection of book objects in a list. Each book has a bestseller field, which is a Boolean that indicates whether the book is a bestseller or not. Now, what happens if we want to remove all the bestsellers from our list? So far, so good. Now, let's try iterating through the list with a for each loop and remove the bestsellers. If we run this code, we'll hit the infamous concurrent modification exception. But why does this happen? When you modify a collection while iterating over it using a for each loop or an iterator, the underlying structure changes, and the iterator detects that something is amiss. To protect against unpredictable behavior, the iterator throws an exception. Solution 1. Collect and remove. One way to safely modify the collection is to collect the items you want to remove in a separate list during iteration. Let's see how that works. Here, we first gather all the books we want to remove in a separate list. Once the iteration is complete, we call remove all on the original list to remove the collected items. This approach avoids the concurrent modification exception and ensures our list is updated correctly. Solution 2. Using an iterator's remove method. Another approach is to use an iterator directly and leverage its remove method. This method safely removes elements from the collection during iteration. Solution 3. Using Java streams, optional. For a more modern approach, you can also use Java streams. Streams provide a functional way to filter and modify collections in a single, concise operation. With streams, we can filter out the bestsellers and collect the remaining books into a new list. This approach is both safe and elegant. So there you have it. We've covered multiple ways to safely modify a collection while iterating, avoiding that pesky concurrent modification exception. Whether you prefer using a separate collection, the Iterator's remove method, or even streams, there's a solution that fits your style. If you found this video helpful, don't forget to like. Accessing collection elements with Java Streams, we're diving into Java Streams and how they offer a powerful, functional style for working with collections. If you're still using loops to process your collections, this video is for you. Let's jump in. Imperative versus functional. Here's a quick example. We have a list of book objects, and we want to print out the names of all bestsellers. This code is straightforward, but you're responsible for managing the iteration and filtering. Now let's see how we can achieve the same result using the functional style with Java Streams. Streams allow you to focus on what you want to do with the data rather than how you do it. Think of a stream as a pipeline where your data flows through a series of operations. Let's convert our previous example to use streams. Notice how concise this is. We call stream on our list, then filter to select only the bestsellers, and finally for each to print out the titles. This functional style is not only cleaner, but also easier to maintain. Let's break down how this works. First, the stream method converts our collection into a stream, which is like a pipeline where the elements move through. Next, the filter method is an intermediate operation that uses a predicate to determine which elements should continue down the pipeline. In our case, the predicate is the isBestseller method. Finally, for each, is a terminal operation that consumes the elements at the end of the pipeline, in this case, printing out the titles of our bestsellers. Using anonymous classes, demonstration. Here, I've written the same stream using anonymous classes to show you the internals. Although this is more verbose, it's helpful to understand what's happening under the hood. The filter method uses a predicate, and the for each method uses a consumer. Both are functional interfaces that operate on the elements in the stream. Let's add a little debugging to see the flow of elements through the stream. We'll log each book as it passes through the pipeline. Using peek, we can see each element as it moves through the stream. This is great for understanding how your data is being processed, especially when dealing with complex pipelines. Java streams provide a powerful way to process collections in a concise, functional style. Whether you're filtering, mapping, or reducing data, streams can make your code more readable and maintainable. If you enjoyed this video, don't forget to like, share, and subscribe to Avenue Braun Tech